Molecular mass. Molecular mass is the sum of atomic mass of the element present in the molecule. That simply define the sum of atomic mass masses of the element present in the molecule. So this is called molecular mass. See, that is, it has been obtained by the multiplying of the atomic mass of each element by the number of its atom and it's adding them together. For example, methane. We can find out the molecular mass. See, that means the molecular mass of methane, which contain the one carbon atom and 4 hydrogen atom. So here only one carbon atom and 4 hydrogen atom. Just carbon atom, the molecular mass of carbon is 12.011 U, and the mass of hydrogen, already we know that 1.008 U. So how many hydrogen atoms are present? 4. So that multiplying of 4. So you will be getting 16.043 U. So this is the molecular mass of methane. Similarly, you can calculate H2O, water molecule. What is the molecular mass of the water molecule? So 2 hydrogen. So 2 into, what is that hydrogen mass number is 1.008 plus oxygen. Oxygen mass number is what? 16.00 U. So only one oxygen. So multiplying this, you will be getting 18.02 U. So this is the finding of molecular masses. Similar way, glucose, molecular mass of the glucose, carbon C6H12O6. This is the molecular formula for glucose. We can calculate here. For carbon, how many carbon atoms are present here? 6. So that 6 into carbon, the mass number of carbon is 12.011 U. Then adding of hydrogen, 12 into 1.008 U plus oxygen 16 into 6. 16 into 6. So here you will be getting the value is 180.162 U. This is the finding of molecular mass. The finding, that is determination of the molecular mass. The next is the formula mass. Formula mass. The formula mass, for example, in a sodium chloride, that means not contain the discrete molecules as their constituent unit. That is in, so in sodium chloride, Na plus and Cl minus having this fluoride ion and the sodium ion. That is, the arrangements is 3-dimensional arrangement. So the sodium chloride, the surrounded by, that is the sodium surrounded by the 6 chlorine atom and vice versa, like this. That is in cubic form. So packing of the sodium chloride you can see in your textbook. The formula of sodium chloride is simply you can use NaCl. So calculate the formula mass, that instead of the molecular mass, and the solid of sodium chloride does not exist a single entity. Okay, so it exists only in a sodium chloride NaCl form. So Na, sodium, the atomic mass of sodium, then atomic mass of chlorine. You have to add atomic mass of sodium as 23.05 plus atomic mass of chlorine as 35.5. So the unit is U. So adding of this, you will be getting 58.5 U. So this is called formula mass. Mole concept and the molar masses. Already you know that the atoms and molecules are very small. That means very extremely small. And that means the number of even a small amount of any substance is really very large. So you have to use the, for example, we denote that is 1 dozen. 1 dozen is 12 items. Score for 20 items, that is score for 20 items. Gross for 144 items. So in such entities, that is this is we use this idea for the mole to count the entities of the microscopic level, that is atoms, molecules, particles, electrons, ions, whatever it is. Okay, so the SI system used, that is mole concept. The symbol simply we can denote MOL. So the 1 mole is the amount of substance that contain as many particles or entities as there are atoms, is exactly 12 gram of the carbon 12 isotope. Already we seen that. That is kilogram means you can indicate. That is 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 gram of the carbon 12 isotope. See, the substance always contains, that is same number of entities, that is no matter what the substance may be. Okay, that is we can determine, that is carbon 12, the mass of carbon 12 atoms determined by the mass of spectrometer and found to be the equal is what, 1.992648 into 10 power minus 23 gram. See that 1 gram of, that is the 1 mole of carbon weighs 12 gram. So the number of atoms is equal to what? So 12 divided by 12 gram divided by 1.992648 into 10 power minus 23 gram. This is 12 gram per mole of carbon 12. This is for carbon 12, and this is for that is carbon 12 atom. Gram per carbon 12 atom. Now it will becomes what, 6 point, simplifying this will be getting the 6.022137 to 10 power 23 atoms per mole. Atoms per mole. Okay, so grams, gram also, everything, the gram is cancelled, just remaining the mole and atom, so that just atoms and per mole. So the number, that is the 1 mole is important to the given separate number is called this is called Avogadro number. This is called Avogadro number. Simply we can denote that Avogadro number is NA or N0. Both are called Avogadro number. Sometimes they are using NA and N0. This indicates Avogadro number. That one scientist name, that is Amedeo Avogadro. Then suppose if you use that using of without 0 means, that is without that 10 power means, it will become after that 16 0 will come, so that we have to write this 10 power. There is so many entities, that atom, molecules constitute, that is 1 mole of the substance contained, that is 6.022 into 10 power 23 atoms. For example, here that is 1 mole of hydrogen atoms is contained. 1 mole of hydrogen atom contain 6.022 into 10 power 23 atom. That 1 mole of water molecules contain the same. 1 mole of water molecule contains 6.022 into 10 power 23 water molecules. Here 1 atom, so that atom. Suppose here means just adding of water molecules. So water molecules, that is 1 mole of sodium chloride. Similarly, say 6.022 into 10 power 23 sodium chloride molecule. So the mass of 1 mole of a substance in gram is called molar mass. I repeat, the mass of 1 mole of substance in grams is called its molar mass. So molar mass of water already we discussed, that is 18.02 gram per mole. And just the unit only changes. 18.1, that is the molar mass of water is equal to 18.02 gram per mole. Mass of the sodium chloride, simply we already we found that is 58.5 gram per mole. Okay. This is called mole concept. Next, percentage composition. That means that many of the time there is the information regarding the percentage of a particular element that is present in a compound as record. There is, suppose an unknown or new compound is given to you. The first question is what is the formula, what are the constituent, what are the ratio, like this. The question will like this. So that means one can check the purity of the given the sample by analyzing this data. Okay, so let us understand the taking example of water molecule H2O. This means the composition of that is here the water molecules contain hydrogen and oxygen. So here the both the elements calculate, that is mass percentage of an element is equal to mass of the element in the compound, mass of that element in the compound divided by molar mass of the compound. Molar mass of the compound into 100 because of the percentage. So here we can calculate that molar mass of water. The molar mass of water, already we know that the molar mass of water is equal to 18.02 gram. Then mass of hydrogen, that is 2 into hydrogen is 2 into 1.008 divided by that mass of that element in the compound. So 2 molecules are hydrogen and 1 molecule of oxygen. Then the molar mass of water is 18.02 into what, 100. So after simplifying this, you will be getting 11.18. So mass of hydrogen is 11.18. Then mass percent, that is mass percentage, not mass of, mass percentage of hydrogen. Then the mass percentage of oxygen. Here the mass percentage of oxygen, mass of oxygen was 16.00. Then molecular mass of the water is what, 18.02 into 100. So you will be getting 88.79. So here some more example also we can tell. For example, ethanol, CH3 CH2OH. The number of carbon atom 2, number of hydrogen atom 6, and oxygen atom is 1. So here the molar mass of ethanol, if we have to calculate the number of carbon atom 2, so that 2 into the molar mass of the carbon is 12.01 plus molar mass of hydrogen, hydrogen is 6, 3 plus 5 plus 1, 6. So 6 into 1.008 plus Oxygen 1 into 16.000. Now this after simplification you will be getting 46.068 gram. Then the mass percentage of carbon you have to calculate. Next, mass percentage of the carbon. Mass percentage of carbon is equal plus 24, because 2 into 12.01, so that 24.02 divided by the molar mass is what? This is the molar mass. The molar mass is 46.068 gram. So here into 100 is equal, you will be getting 52.14 percentage. That is mass percentage of carbon is 52.14 percent. Then mass percentage of hydrogen. Mass percentage of hydrogen, 6 hydrogen atoms, so that's 6 into 1.008, it will become 6.048 divided by the molar mass of 46.068 into 100, so you will be getting 13.13 percentage of hydrogen, the mass percentage of hydrogen. Then mass percentage of oxygen. Mass percentage of oxygen, simply 16.0, only one, so that this everything here is gram, just put a gram, so gram, and 46.068 gram into 100, so you will be getting 34.73%. So mass percentage of oxygen is this. So this is the way of finding percentage composition. Then empirical formula. The empirical formula is to represent the simple fold number ratio of various atoms present in the compound, whereas the molecular formula, that is shows exact the number of different types of atoms present in the molecule. For example, ethanol, C, number of carbon atom 2, number of hydrogen atom 6, number of oxygen atom 1. So it is the mass percentage of the various element present in the compound. That is, the empirical formula can be determined. That means the molecular formula can further be obtained if the molar mass is known. Okay. Thank you.